All right. I want to do a little bit of new stuff today somehow. Let's see. Okay. So, 42 says this. Holy shit. Crouching type, a hidden limit. Real quick. I freaked my Math 90 students out this morning when I asked them what that was. What is the absolute value of x? I'm going to freak you guys out too, apparently. This is so desperately wrong because x could be negative. So it totally depends on what it is. So it's actually piecewise. So personally, I hate absolute value. It's the most evil function, really. In one sense, it's the most easy function because it makes everything positive. But what does it really do? If the interior thing is negative, what's it do to it? Changes the sign. This does have relevance to number 42, by the way. It didn't just go crazy.
Could you change the answer to the square root of x squared?
Yes, but that's just as bad as this. It doesn't really tell you what it really does. Does that make sense? So I agree with you that these are the same. Does that make sense? Square root can't be negative, so if you say this is true, that's not true, because x could be negative. And then you're telling me square root equals negative, right? Which is insane, which is a sign of insanity in mathematics, right? Or at least not understanding. But this really explains what it does. So what's it got to do with this problem? This problem is interesting because it has an absolute value in it. So you got to understand this. Totally depends on what the values are that you're using. So the limit as x goes to negative 6. Oh, they don't even... Okay. It's not quite what I thought, but that's all right. It's going to be the same idea. They should have taken it from one level to the other.
So do you take out 2 on the top?
So let me ask you this. So that's the idea we're going to use. This is related to 0, of course. Where does this change? At negative 6, which of course is why they built it so it's all related to there. For this limit to exist, what must be true? The limit from both sides have to be equal. So if I come at negative 6 from below, I don't have to write the absolute value anymore. Now let me say and look at this and look at that. Look at these. Negative 6 from above. Sorry, there's still a bottom there. If I come at it from above, let me start there. What kind of numbers will end up in there? Positive numbers. And I love that. It's a very open-ended question, but it's absolute value. So that's the only thing I care about. Is it positive or is it negative? That's what the absolute value cares about. So if I come at it from above, these are going to be positive, right? So do I really need the absolute value? No. So that's what it looks like from above. What's it look like from below? Well, you could do like that.
I have a question.
Yes.
Well, isn't it for all absolute values, like, wouldn't it just be a cusp if you...
True, and this is what that's saying, really.
Oh, okay.
Well, if you realize what I just said with the negative x and the positive x,
Right.
so above 0, it looks, or 0 and above, it looks like that, y equals x. Below it looks like y equals negative x.
So it couldn't exist, right? 'Cause-
The limit could exist, right? But this is a little more not advanced, but a little bit different than, well, let's work this out. See, if it's just an absolute value, the limit will exist because it's continuous through there. And I know that's section 2.5, but we've already talked about continuity a little bit, right? So obviously the limit's going to exist because for just a regular absolute value, it agrees from both directions. You with me? I like it. Do the slopes agree? No. One slope is negative 1, the other slope is 1. Oh shit. Right? So that'll come up later. We'll start talking about differential ability. Right now, how does this reduce? 2. So the limit as x goes to negative 6 of 2 is 2. That's crazy. All right, I like it. And how does this? Negative 6. Negative frickin' 2. So that limit is negative 2. Are the limits the same? No. This is weird shit. What I really want you to understand, no matter what x you put in there, if it's above negative 6, this will reduce to 2. That's what that's saying. So what does this actually look like if you graph this? For every x value above -6, it looks like 2. And at -6 is undefined, of course, but sure. And for every below -6, it's going to be -2. And let's see real quick. I got this bad boy up here. Has anybody tried to graph this? What did I say yesterday? If you're not graphing some of your problems, even if they don't say to graph them, then you're a little insane. I don't think I said that. That's basically so let's put this in here, and I'll show you where the absolute value is in your calculator if you don't know. Parentheses 2x plus 12 divided by math num absolute value. Math button looks like a good button to search through, right? Absolute value of x plus 6. Let's see what happens. Let me zoom 6. Oh. Look at that shit! Look at that shit! That's what we just proved. On one side it looks like 2, and the other side it looks like -2. This is something we call a step function, because again, math people are very creative. That looks like a step. Call it a step function. So that's what we call it. I like to diss on math people. For some reason I am one. Alright, so that's how you have to look at that problem. Any absolute value inside of a limit, any absolute value in general, if you know something, or you can break it up into the cases of when it's going to be positive and when it's going to be negative, you can actually simplify. You can take the absolute values away. If the interior number is going to be negative, then it's the opposite of what that interior number is. Does that make sense? Yes, sir.
I see how you simplified the positive one down to 2, but not that way to -2.
Well, there's a negative there.
Oh,
So,
okay. So,
yeah, it's the same as that, except there's a negative there.
okay.
Yep.
So you still cancel that plus.
Totally. Everything works exactly the same as that, but there's a negative at the end. Yeah, cool. Because you factor 2 out, kill the x plus 6. Is that cool?
So whenever you have an absolute value, you have to solve the limit like that?
Yeah, in the cases where you actually have to do something with it. And how do you? And really, how many cases did I have to look at? 2. And how do you solve this equation? This is going back a ways. How do you solve that equation? 2 cases. Hey, so it seems like anytime you want to actually do something with an absolute value of a variable expression, it's going to involve 2 cases. Yeah, of course it does, because there's only 2 things the number could be inside, positive or negative.
And they're both undefined too.
Yeah, exactly. It's undefined at -6. So it's undefined at -6 because then you got an indeterminate form, right? Cool, I like it. Hey, what's up? You all right? What's the matter? No, not you, sorry. Behind you. Everything okay?
I think so. I'm gonna...
All right, that's a good place to be. If you're too confident, you might not understand what I was saying. But if you're like, that sort of makes sense, you're in a good place. Okay. Oh, shit. Well, they got like 5 minutes? God, Tuesdays. I don't know if you noticed, that's why I put all our tests on Wednesdays. You notice that? So we have more time. Thanks, Jeff. All right. So I desperately, let's see, there's just no freaking way. Let me at least, I made this handout the other day and you'll get it maybe tomorrow. At least I want to talk about, we talked a little bit about the idea of where epsilon and delta come from yesterday. Let me just remind you guys, let me do this at least, and then we'll head out. Let's look at a really simple example, and just to remind you guys, I think I said this yesterday, we always look at really simple examples first, just to flesh out the full process, even though we do a lot more shit than we need to with the simple examples that will help us when we get to the harder examples. So let's take something very simple, something like, what would that limit be? That's crazy, right? Just plug a 1 in because there's no problems in that polynomial at 1. I know the limit is 2. Now what that really means is if somebody gives me an epsilon, given some epsilon, and whenever you see the letter epsilon in a proof, really represents a very small positive number is the intention of it. It could represent 18 billion, but it's trying to represent something just barely above 0. Given something, so somebody's going to ask me, all right, so here's my 3 minus x squared. Why'd you make it 3, Jeff? Just to be an asshole. All right, so square root of 3 is like 1.7. So it's roughly like that. You guys will give me a break, right? That's too bad. So at 1, it's approaching 2. Look at that. That worked. Right? As it goes to 1, as it goes to 1, it's approaching 2. And of course it gets there. It's a nice function and all that kind of stuff, so it's continuous. So if somebody gives me some epsilon, meaning some distance away from this. All right, so somebody says, I want you to get within this much. So let's say epsilon in this case, let's say it's like 0.5. You with me? In fact, let's make it that. We'll say epsilon is 0.5. They want to know, how close do I have to be? Let me just fudge that a little bit. How close do I have to be here so that I actually do end up in there? And the whole idea is, as this person decreases epsilon, I can just decrease delta so that I can always, if that really is the true limit. If that's not the limit, if I thought the limit was this, then already I'm screwed. If I go here, that doesn't even include that output, right? This is from there to there. It doesn't even include that output. I can see already it's not. It can't be that. That can't be the limit. It's outside of that range. So what this is really saying, no matter how close this person says you have to be, I can always find a delta around there that I actually can be that close for my outputs. No, I keep saying this, but I desperately want to show you on the calculator how to do this. So given that epsilon, meaning I want to be that close. In fact, let me put this in general. Somebody gives me epsilon, so they want me to be within epsilon between the function value and the limit. Let me stop there. Does that make sense?
Yeah.
They want the outputs to be within that much of the real limit. And I got to find delta so that this is true. When this is true, then this is true. That's what I have to find. All right, it kind of makes sense. The smaller this gets, the smaller this probably has to get for that to still be true. Right? So if I make this 0.5, so let's make this more specific to this situation. What would this look like specifically for this situation? It would be 3 minus x squared minus 2. I want that to be less than 0.5, right? How are we doing so far? I'm just plugging stuff in here, right? Are you guys cool with this?
Yeah.
I've shown you that before. All this says is I want the distance between the outputs and the limit to be less than some epsilon. I want to be that close to the actual output. Right? So if I said here, well, I'm here. Holy shit, I'm way far away from that output. So that's way too far away. I need delta to be smaller so that I end up within this region. So let's look at this visually real quick. I desperately want to show you this before you head out of here. So if you want to play along, if you got your calculators, don't freak out too much. Obviously, I've got to go deeper into this tomorrow when we have more time. 3 minus x squared. Let's plot that. And then let's plot these two things. So we're interested in, this is 2 here, right? So what is this here and this here?
2.5.
2.5, 1.5. So graph 2.5 and 1.5. So let's graph those and see what happens. Now, this is an excellent place to show you one of the coolest things. Now let's show everybody. You guys can see that too. Alright, here's one of the coolest things on the calculator. This is the most useful thing on here. Everything's happening in there, right? I'm curious about at 1. Everything's happening here. So I'm going to use zoom box. So let's do this. So you see how it has a little cursor dude? You guys ever use zoom box? It's the bestest thing. So just go with me. Everybody got the little cursor dude? Put it around about where I've got mine, right? If you hit enter, that's one corner of a box that I can now open. And then this is like Google Maps where I'm just going to zoom in on that little area there, right? So put it about like that. Are you guys doing all right? Those of you trying to play along with me?
That's intense.
How are we doing? Zoom box. If you hit enter, it'll be one corner of the box. So you want to put the cursor where you want one corner of the box to be.
That's gnarly.
Where do you
Enter.
put it? Negative.
Yeah. Now if I find the intersection, now look at this. If I find the intersection between these and the actual function, it'll tell me what those x values are. I can see what delta has to be. So for a very specific epsilon, I can find what delta has to be by just finding the intersections here and see what that x value is, and here and see what that x value is. That'll tell me on the x-axis what my inputs have to be, so that when you follow them back up, they'll actually be within epsilon of the function value. So if I have a function, and I got this little interval here, if I follow them back up, this would be the epsilon interval, right? That's how epsilon and delta interact. So I always, no matter what epsilon somebody picks, I always have to make a delta so that it fits inside of this. Okay, Jeff. All right, so I'll tell you what. Let me go ahead and give you this. Bring this back tomorrow. But just in case you actually look at this, maybe you can start to digest it a little bit. Up there. And we got to get out of the way of this next class. They're going to start to use it. No, just bring it tomorrow. You can not look at it at all if you don't want to at the moment, but I'm kind of hoping some of you might just start to see how this thing works. Oh, shit, I see that thing. If you get an extra one, just keep it. Oh, shit.